Reed here with Wild Night Skies, and I want to do a full tutorial from start to finish on the Rho Ophiuchi Nebula, which ends up being a lot more colorful than I ever imagined. I've really never even tried to take photos of it before, but now with some new equipment and some new techniques, it turned out really nice. So, if you stick through this tutorial, it's a little long, and I'm new at making YouTube videos, so I kind of probably blabber on and kind of ramble a little bit, but if you stick through it, I hope you get something out of it. I hope it's kind of interesting for you. But we go through, start with Pixinsight and all the processes that I like to use, and then dive into Topaz Labs AI, which is a standalone program, and Adobe Lightroom, Adobe Photoshop plugin, and then also into Photoshop as well. And we can see all that, in the video if you stick through it, which I hope you do, but we'll see. It's a little bit long, 37 minutes, I think, of actual processing video. So anyway, I used a Red Cat 51 APO refractor and a ZWO ASI 294 MC Pro color cool camera for the acquisition of the subframes. 39 of them at 5 minutes long each, and taken a little bit outside of my town, about 8 minutes from my house, out in the country. I have an observatory out there. So a little background information on the process of taking the image, and hopefully I'll do some videos that capture that as well. But for now, let's jump into Pixinsight and get to processing. All right, let's open up Pixinsight. Try to make this an effective video, but probably speed some places up where the computer processes things. Some of these processes take a while, so anyway, try to make it as helpful and instructive as possible. First of all, we're going to load the processing icons that I have saved. I have them saved on a hard drive. So it kind of just helped me stay organized. I start from the bottom and go through upwards to the top to see what processes I like to apply to images and what's kind of helpful for me. I use a lot of plugins, all free for the most part, besides some of the exterminator plugins, which are well worth the cost. I'd 100% check out RC Astro for those. But besides that, I think most things are free and very helpful. The scripts, the utilities, I'll probably post another video on how to install those. There's plenty. You can certainly just search for how to install scripts and utilities for Pixinsight, but they're super useful. Tons of them are free. I really like them. I use them all the time on pretty much every astrophoto. So where we are here, let's go ahead and open our batch. Well, we'll start here with our files. Kind of go to the desktop and open up the Rho Oph file. I've already blinked the lights. I have another video that's really short and simple. Not a ton to learn from it, but if you've never blinked any photos, it's very helpful. It's an extremely helpful process to weed out the bad photos if you have any. I usually don't have that many, especially with my Red Cat 51. It just takes great pictures, and the guiding's awesome, especially in my observatory. So anyway, blink, I usually weed out maybe 3 or 4 out of 60 pictures. I think this particular one, we have 39. So we've got 39 lights, which I call blinked, after I've previewed them. And then I match it with 39 darks from a dark library that I've taken from my ASI 294 MC Pro. And then I always take dark flats and flats, take 40 of each every day. Usually the morning after, because I don't like to stay up all night. That's why I have an observatory. So I close it up,
take pictures with everything closed up, and the flats and dark flats turn out perfect the next day every time. And then we set up a pre-processing folder that we'll use when we use the weighted batch pre-processing process. So that's kind of where we are right now. I'm going to move it off screen. Again, we've loaded our processing icons. We'll hit script, batch pre-processing, weighted batch pre-processing, let it load. And we're going to just go ahead and reset everything. Back to the defaults, actually. I just wanted to do that because I typically don't stray far from the defaults. They work really well. So right now I'm just clearing out everything from the last photo that I processed in here. The main thing that I change when I reset to factory defaults is under the lights tab. I don't like interactive mode, so I make sure that's unchecked, and I don't like auto crop, so I make sure that's unchecked. From there, pretty much all the defaults are good with me. I add some options in post calibration, mostly drizzle, just to up the resolution of the photo. So we'll just hit a directory, and all you really have to do here is go find the file folder, basically the directory that holds everything. Select it, select that folder, and it's going to import everything. This doesn't always happen if you've taken the photos with maybe a DSLR or a different software program that doesn't use fits headers and label things correctly. But if you're using something like Nina, which is what I use to capture everything, all the data is in the files, and they load it perfectly, as you can see here. So go to lights again just to check to make sure that the interactive mode and auto crop is off, which is good. Go to calibration. I have one-shot color cooled camera, so I don't have to use a lot of time switching between filters and things like that. I use right now just a simple hydrogen alpha and oxygen 3 filter from ZWO, and it works fantastic. I'd love to upgrade in the future, but right now it's just a relatively affordable filter that I love, and it works super well both in in town, right at my house in my driveway, and also out in the country where my observatory is. That's just about 6 minutes from here, so it's not a lot different, but it's pretty it's noticeably darker out there. Let's just say that. So anyway, I apply CFA to all the images, and then here, this is why we load our processing icons beforehand, because I use a cosmetic correction template that's loaded right here that I learned from Light Vortex Astronomy, and I would highly recommend going through some of that tutorial or finding another one online, because I have not made one, and it's well worth learning just the setup for cosmetic correction there. It gets rid of star trails and even gets rid of star link, which is absolutely fantastic, because a lot of my frames actually end up having full Starlink satellite trails in them, which is kind of crazy. I also have a Starlink satellite dish, so I do utilize their satellites, which, that's good for me, right? So they get my pictures, but I use their service, so it, washes out. It's all good. So I then apply just the auto settings to everything. I like to do calibration for diagram to make sure the lights, we start out with our light frames. We subtract our master dark, master flat, and then we have our calibrated lights that we stack. So I just like to make sure everything's okay there. Drop down here to the output directory, and I always like to make sure that I select my new pre-processing folder that I make. That's where a bunch of files will be generated by this weighted batch pre-processing process. So from there, I almost always forget to jump in here and do drizzle configuration. I want to enable it and scale it up by 2. Just doubles the resolution, which helps a lot, and we want to apply that to all groups. It makes the picture a lot more detailed and easier to work with. So again, we'll check diagnostics now. Looks like everything is good. Hit OK. We're going to hit run and hit continue. And from here, this is just going to, kind of rip through each one of these processes. Some of them take a lot longer. The local normalization reference and local normalization process in general, along with integration and drizzle, all take the longest. So these last 4 end up being probably 60 to 80% of the processing time. Everything else goes pretty quickly, as we'll see it kind of run through. But for now, I think I will fast forward from here and see in about, I don't know, maybe 10 minutes. Anyway, that was a good use of time during the weighted batch pre-processing time suck, you could call it. So we're going to say done there, exit there, and we're going to open up, we're not going to open up that, I'm going to close that out, I don't even want to see that. Open up this, bring it over here so we can see what we're doing. Go to pre-processing folder, go to the masters folder. We can blow this up just so we can see what's going on here, expand these out. We've got the RGB complete photo, and then we have the RGB drizzle 2x photo. So we're going to open that up in Pixinsight. Shrink this back down, close this mask off. And I like to expand it and rename it. I'm going to call it I think we'll just call it Rho Oph. I always like to stretch it, auto stretch it, just to see kind of where we're starting at. And kind of love this. We're starting with nothing. I'm going to take a picture though of this after I remove the background. I always use dynamic background extraction. At least almost always. Seems to be most effective for most of what I do, so we will use that. I don't want to cut out a lot of the nebula, so I know where it is. So I'm going to delete that one, delete that one, delete that one, delete that one, delete that one. We also don't want to have any bright stars in there, or a lot of stars in general, which is tough with this one because it has mostly its nebulosity, so it's kind of tough to find places to put your background extraction points in without taking a lot of the nebulosity out. So we're going to do that. It's also kind of cool. We have globular cluster here, big globular cluster M4 there. Another one down here. I have a feeling this one's going to get cut out just because of the way posts and things like that work. I'll try not to cut it out for YouTube, which is nice. I love YouTube because we have more flexibility and bigger, more like cinematic views of photos, which is great. So first, when you do this process and you set up all of your points of calibration and extraction, if you just go ahead and execute it, you'll have to redo it, and you want to have all the points the same. And so just drag the triangle down here and make a copy of it. And then what we want to do for the correction mode, I always start with subtraction. It makes the biggest difference for me for some reason. I click execute, and then I close out of that. Yes, yes. Get rid of the screen stretch, the auto stretch, and then re-auto stretch. And now we have a lot more to work with here. We'll open up this process again, switch to division, execute it again, and now we've successfully gotten rid of that nasty, nasty green background. which is great. And then I like just to delete that to keep things clean. So right now, just for the sake of this video and for some other videos I might make, I'm going to go ahead and save this as we're going to jump up into the main directory and just call this Rho Ophiuchi background extract. So we can see kind of like where we started. And we always save these as XISF, but we can save them as TIFF files anytime. And we need to save them as TIFF files later, because that's pretty much what Topaz AI, Photoshop, Lightroom, After Effects, everything uses TIFFs. They don't use the XISF. But the XISF holds a lot more data. So we start with that. Okay, so next, after we've done the background extraction, we go up here to, I have this auto color icon here. It doesn't do anything. This is actually the SBCC icon, but it just keeps me in order, so I know what I'm doing. So then we run up here to scripts, utilities, auto color, and we just run the auto color script. So I will see you in a little bit after this finishes. All right, and there we have our auto color script done, looking better. Things have gotten rid of some nasty green tint that we never liked. Gobblier clusters are looking white, the stars look a little whiter. All these things look better. So then next we're going to open up our spectrophotometric color calibration process, and I just leave it basically at the defaults. You do want to have the catalog Gaia DR3SP downloaded, and you can look at some other tutorials if you want to for how to get that done. And what that does is it actually looks up the true color of the stars and the background based on astrophotometric measurements, and gives your stars a true color. So maybe they're not just pure white, maybe they have a little tint, blue, red, orange, whatever it might be, white, whatever. And it also helps with the background. So anyway, the SBCC process is very valuable, and they're relatively new. I haven't used it a ton. Well, I have used it a ton now, but I hadn't over the last 7-8 years because it's only come out recently. So well worth using. Next up, we have RC Astro's paid plugins or utilities. Blur Exterminator is absolutely fantastic. You do have to have StarNet enabled, and you have a few steps to get that to make sure that's done correctly. You also have to have, you may have seen in the intro to this, you need to have an NVIDIA graphical processing unit, GPU, to make sure that this works. It doesn't work with anything but NVIDIA, RTX series especially. I think I've got the RTX 3070 Ti in this computer. Fantastic processor, extremely fast, and very, very helpful for a million things that we do, especially with astrophotography and filmmaking. So that process just finished up. Again, there's some really good simple tutorials on how to get set up for using the CUDA cores of the RTX series or just NVIDIA graphics cards in general by Dark Archon, which I also should link in this video and will. But he is fantastic. He's one of the best contributors to Pixinsight for free that I know of, at least. I'm a big fan of what he's done with StarNet and a lot of the neural networking AI processes that are enhanced using NVIDIA's CUDA cores. So anyway, all that is out of the way. So next on to RC Astro's Noise Exterminator. This again just kind of denoises some things, makes things a little more smooth, clears things up. It's just another great AI process to use using those neural networks with your CUDA cores. And you can see the difference every time. I'm going to go ahead and save this. And this time we're going to save it as, let's see, extract. And let's go back here. Extracted and exterminated. Save it, 32-bit. Okay, doing this again because I'd like to kind of show a progression as we go here. So the next thing we're going to turn off the auto stretch, and then here's where I start using a few scripts. The histogram transformation you can do on your own. I used to do it all the time, but I found out Easy Processing Suite is really easy and it does a really good job. It pretty much by default does as well as I can do. So I mess with nothing. I just let it do its thing, and it stretches the image for me. And I mean, honestly, to me, it really looks beautiful. I love it. So the next thing I do then is I don't always need to reduce stars, but I typically really like to reduce stars. They get in the way a lot, but in this particular photo and a lot of photos I am using an H-alpha and oxygen 3 filter, so narrow band, which reduces the star size. So it's not super necessary to do in this kind of a photograph that we have here, but if I didn't have the filter on, a lot of times the stars get blown out and they're kind of obnoxious. So I make a regular habit of reducing the star size, basically. And I'll show you in a second once this mask is generated again using Dark Archon's process for Pixinsight, which is enabled by NVIDIA's CUDA cores, especially with their RTX series graphics cards. Some of these processes can take a really, really, really long time if you're using your CPU and maybe overheat it and do all kinds of stuff. So you absolutely can still do this. Most computers will work just fine, but if you have the RTX series graphics cards, NVIDIA in general, make sure to set that up. Again, just Google Pixinsight Dark Archon, DARCHON, I believe. I probably spelled that wrong. But anyway, look him up and look up StarNet and neural networking. It's a bit of a tutorial, takes a little bit of time to really get set up, but it works well. So anyway, I created that star mask, so we have a good star mask now. I always use, when the stars are already small, I use atom blocks de-emphasis method because it's kind of less intense than the morphological selection, especially if I put it at 10, which I do a lot of times when I'm just doing pure color photographs because the stars can get way blown out. But anyway, in this instance, atom blocks de-emphasis method works fantastic, so we'll run that. Shouldn't take too long, but if it does, I'll fast forward and see you in a few seconds. Okay, there we have our stars reduced, so they're less obnoxious. Of course, we can still see the triple star Rho Ophiuchi right there, and a few others. We have M4 down here in the corner, the globular cluster. And let's see here, what do we have? We have NGC 6144 right here. And so anyway, some pretty cool elements to this photo. So the next thing that we want to do is actually remove the stars so that we can work on the nebula all on its own. So we'll take StarNet, make sure to create a star mask. We've already stretched the image, so we don't need to check linear data. And then just apply that globally and let it run. Again, probably fast forward. All right, we've got our star mask here and the stars. So we want these because we're going to add them back later, right? So you want to make sure you have your stars So now we have our starless image here. But we definitely want to add our stars back later. So that's why we do that. So next thing we're going to do is do a little curves transformation. Pop up a preview here. Let's try to increase the contrast a little bit by making our nice little S curve. Try to pop some details. Really make this pop a little bit. We'll hit the saturation, bring that up. Just want to see what things look like. Maybe bring the, nope, I'm not going to bring the blue tip down yet. Yeah, I think that looks okay for our first go. This is where it kind of gets just up to your own taste and a lot of testing here and there, back and forth. But I do like to use another utility. I think it comes in automatically. The color mask is just awesome. This is kind of like a key. I would highly recommend using this if you don't use it already, if you don't know about it. Color mask is how you can really make the colors you want to see pop out. So that, just taking the mask off, I don't want to see it. I want to see what actually happens. So let's open up a preview here. Let's increase the saturation a little bit. Let's increase RGBK, the color, the brightness of it. Let's add some blues to it. And then I want to change the hue, or the, the kind of the blue hue component of it here instead of being greenish. I really like the blue color. I'm a big fan. So we're going to start with that. Yeah, we're going to start with that. Don't want to overdo it. I'm going to make it kind of obnoxious or anything, but I really like that as a start. So we get that going. And then next, let's do another, we're going to do this a few times, so remove that mask now, and do another color mask. And this time, I'm going to try to get some yellow. I think that's what is over there. We'll see. Yeah, there's a little bit, yep. So let's apply that mask. Curves transformation, open up a preview, brighten it up, and saturation, make it a little more gold looking, I like that. Yeah, not too much green, that'll be good. Apply that, close that. And if you're bored with this, just skip through, you know how to change the colors in a Astrophoto. And then we'll go again. Here we go. Utilities, color mask. Now let's do red. I'm going to bring that out. Not a lot of red. That's not. Oops. First we need to get rid of our last mask. Okay. And then apply this mask. Okay. Curves transformation, preview, red. Boom, like that, pop. Saturation, pop a little bit. Maybe even make it a little brighter. Just give it some nice coloration there. Okay. And one thing I'd like to do really quick, move that mask and then to the whole picture, let's do some dark structure enhance. And I didn't change any of the default settings. So if I go fast, it's because it's default. You don't need to change anything, it works really well. You can increase the power, the intensity of a lot of these processes, but I typically leave them at the default and it works really well. So, alright, we've got that. And then, just to see what happens, let's do one more color mask. let's see what magenta has for us. And we'll just slap that on there really quick too. Open up curves, preview, brighten it up, enhance saturation. So let's see what we got going on here. You don't want to blow things out and make it wild, but do want to kind of see what's going on. That looks pretty good. Let's close that, close that, close that. And then just to kind of make things look good, I'm going to process, convolution, sharpen things up a little bit, do a quick default unsharp mask. We will denoise things and make things look really clean using Topaz AI and Photoshop, so we don't need to worry about that really too much right now. So the next thing that we'll do is open up Pixel Math and the expression editor, and we're just going to double click on Rho Oph and say plus our star mask. Say OK, and then just to show you what we have going on here, these are all, again, default settings. We're going to replace this image with an image with stars. There's nothing else you need to change, so I don't even open that usually. Just hit apply global, and then boom, stars are back, and it looks pretty beautiful, honestly, in my opinion. And from there, we're going to save it. And I usually like to call this just processed. Let's say Rho Oph processed in that same file. And just save it with the defaults. And then I also like to save it same thing as a TIFF, because TIFFs, 16-bit TIFFs, are what everything else, all our other programs that we use, are capable of using. So I saved all those in the pre-processing folder, which I don't really like, so let's bring them back into the main directory. And then what we're going to do, I'm going to move this off screen, open up Topaz Denoise. This is another paid plugin, but it's well worth it. I paid for a bunch of them, probably too much. But I love them. They work fantastically, so worth it to me. So we'll open up the TIFF file, kind of leave the AI model alone. Let's see here, we might reduce some color noise a little bit more. It's updated. I don't know. I don't like messing with the AI model too much, but it's nice to. It has some really good properties to it. I mean, look, I don't know if you can tell what YouTube's going to do to this, but the smoothness, it's pretty incredible. Not a lot I can say about it, honestly. It just works. So it's just really worth it to me. I can move this around, go look at the star. It's just a lot smoother. Don't have any of that graininess. Which is beautiful. So I'm going to go ahead and save it, and I just usually name these Topaz because I have Topaz Sharpen, Topaz Denoise, Topaz Photo in general, which does a bunch of things, but it turns out for me that just Denoise typically does what I need it to do and does it really well. So that's what I stick with. Okay. That's done. I go to Photoshop. Typically what I do is I just start out with the camera raw filter. I really like it. This probably kind of dates me. I used to use Lightroom when I first started, and I really like it. And this is just kind of what Lightroom used to do for me. And here we're just going to mess with stuff. So don't take any of this as gospel by any means. I'm just going to try to make this picture kind of look good in my eyes. May not look that good in someone else's eyes, and that's fine. But to me, I have certain kind of ideas of what I want it to look like, and that's what we're going to work for. This picture in particular, I really love the colors, and I just kind of want to boost them. I don't want it too crazy. I don't like things looking fake. But unfortunately, a lot of times on Instagram, YouTube, whatever, online, you kind of have to make things a little out of control. Otherwise, people just scroll away. I love it if people would just look at our normal photos and say, "Hey, that's beautiful," and it's normal, and that's kind of just what it's supposed to look like. But that doesn't seem to be the case most of the time, which is fine. I like to call this space art. I say complete, it's done. And first, save it as a TIFF, which this, say it's a huge file, and that's fine. And then we go here, and then I'll also export it as a PNG into the same file so that I can upload it to Google Drive and then load it onto Instagram and YouTube and things like that. So I'm just trying to save it in the wrong spot, which I do not appreciate. Save. And there we go. I mean, that's the Rho Oph from nothing to extremely colorful. I mean, I think that's a pretty cool area of the Milky Way to photograph and to process and to enjoy in general. So I'm going to close out of that. We can jump into this really quick. And photos, so we can get a full screen view, and it looks good. I really like it. Yeah, you can kind of see the editing process. It's kind of nice. All right, well, anyway, I really hope this was helpful, interesting. Hopefully somebody got something out of it. If you did, please, maybe like this video, subscribe to my channel. And I have a new channel. The algorithm is tough when you're new. I love posting shorts. I like to animate my astrophotography. There's a lot of fun things I like to do. It's just hard to get started on YouTube. And so anyway, I appreciate anybody that watched this for the entirety of it. I'm also going to split it up and try to make this into multiple different videos that are hopefully helpful in different segments. So anyway, it's been fun for me, and I enjoyed doing this very much. I'll probably make more full processing tutorials, whatever, examples in the future, just because I like doing it, and it makes beautiful pictures. So again, thank you very much, and we will see you in another video. Thank you.